Great. Good morning, ladies and gentlemen. My name is David from RCM Online College. Today, I want us to look at this paper called Financial Management, which is being tested by Kenya National Examination Council under diploma courses. This paper, Financial Management, is being done by those who are doing diploma in business management, those who are doing diploma in investment management, and those who are doing diploma in human resource management. So today, we are going to look at a concept called net present value. Net present value, which is being tested under this paper. So as RCM Online College, we are offering this course here through Zoom. And then after that, you can also get a video of the same class, so that you can use it for your revision. So we welcome you all who would want to pursue diploma courses for the NEC. We welcome you to join us and pursue your courses here with us. We charge affordable rates. Per unit or per paper, we charge 1,000 Kenya shillings. So you are most welcomed. So let us now start our class for today. So we are going to look at a question in November 2022, which is question 4B. Question 4B. So this question tests the concept of net present value. Tests the concept of net present value. Tests the concept of net present value. So allow me to read that question so that we can look at its solution. We can look at its solution. So the question reads like this. 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 Jenga Limited intends to invest 5 million Kenya shillings in a project whose expected useful life is 4 years. The expected net cash inflows and the corresponding certainty equivalent coefficients are as follows. We have year column, we have net cash inflows column, we have certainty equivalent coefficient column. We are given the risk-free rate as 5%. The risk-free rate is 5%. Requirement number 1, determine the net present value of the project. Number 2, advise the management on whether to invest in the project or not. So my good friends, where do we start with this question? So let us start with coming up with a table or a schedule. So let's have years here. Then let's have net cash inflow. Let's have net cash inflow column. Net cash inflows. Net cash inflows. So we have year 1, year 2, year 3, year 4. The expected useful life of the project, we are told it's 4 years. That's why you can see we are writing 4 years, up to 4 years here. Then the net cash inflows for year 1 is 1 million. 1 million. For year 2 is 1.5 million. 1.5 million. For year 3 is 2 million. Year 3 is 2 million. And year 4 is 2.5 million, 2.5 million, 2.5 million, 2.5 million, 2.5 million. Then we are given the certainty equivalent coefficient. Certainty equivalent coefficient. Certainty equivalent coefficient. Certainty equivalent coefficient for each year. That is for year 1 is 0.95. For year 2 is 0.80, 0.80. For year 3 is 0.70. And for year 4 is 0.60, 0.60. So, my good people, when the examiner has given you cash inflows, then he has also, or the examiner has also given you certainty equivalent coefficient. You are required, you are also given here the risk-free rate, the risk-free rate is 5%, is 5%. The risk rate is 5%. So when you are given cash inflows, then you are given certainty, you are given certainty equivalent coefficient, certainty equivalent coefficient. What does the examiner want you to do? What does the examiner want you to do? Of course, we know the examiner wants you to get the net present value of the project as per the requirement and then advise. But this is a different concept. This is a different concept. This is a different concept. This is a different concept in which, when you are told, in this case, that the examiner wants you to use, in this case, when the examiner has given you certainty equivalent coefficient, the examiner wants you to use the certainty equivalent approach to get the NPV. The examiner wants you to use the certainty equivalent approach. The examiner wants you to use the certainty equivalent approach to determine the NPV, of this project, So what does this approach entails? What does this approach entails? Certainty equivalent approach is a method. This is a method. This is a method. This is a method used in decision, used in decision making, under uncertainty, It involves determining the amount of money, the amount of money. It involves determining the amount of money or value that an individual would consider to be equivalent to a risky project, equivalent to a risky prospect, So certainty equivalent approach is a method used in decision making under uncertainty. So here there is uncertainty. There is uncertainty environment. It is under uncertainty environment, whereby you are not sure. The probability here is involved. Probability here is involved. Whether you will succeed, you are not sure whether you will succeed or not. You are not sure whether the project will succeed or not. So here, when you want to use this certainty equivalent approach to determine the net present value, and you have been given the certainty equivalent coefficient, therefore, you will have to get the certainty cash flows. You will have to calculate the certainty cash flow. You will have to calculate the certainty cash flows. You will have to calculate the certainty cash flows. So allow me to wrap this part. So that now we can insert the column of certainty cash flows. Certainty cash flows. So this is the column of certainty cash flows. So how do we get these values? Of certainty cash flows? Certainty cash flows, we are going to get them by taking the cash inflows, the historical, that is the original. We are going to take the cash inflows, which we can call them the original, then we multiply them by the certainty equivalent coefficient. In short, SEC. We can abbreviate this as CEC, certainty equivalent coefficient. SEC, certainty equivalent coefficient. So how do we get these certainty cash flows? We said we are going to take the cash inflows times the certainty equivalent coefficient. So let's work out. So for year one, we are going to take 1 million times the certainty equivalent coefficient for year one is 0.95. What are we getting as the total? 950,000. 950,000. What about for year two? We are going to take 1.5 million times 0.8, which is the certainty equivalent coefficient for year two. We are getting 1,200,000. 1,200,000. What about for year three? Year three, we are going to take 2 million times 0.7. 0.7, we are getting 1,400,000. 1,400,000. What about for year four? 2,500,000 times 0.6. 0.6, we are getting 1,500,000. We are getting 1,500,000. Now we have the certainty cash flows. Certainty cash flows. So these certainty cash flows are the ones which we are going to use to determine our net present value of the project. So when you reach here, now you need to look at these cash flows. How they are behaving. Are they regular cash flows or are they irregular cash flows? Are they fluctuating or they are constant? So when you look at these cash flows, you can see the first year is 950,000, second year 1,200,000, third year 1,400,000, fourth year 1,500,000. So they are not regular. That means they are irregular. They are irregular cash flows. They are irregular. They are dancing. They are dancing. So which method of discounting are we going to use here? So the method of discounting which we are going to use here is called PVIF. PVIF, present value interest factor. The method we are going to use here for discounting is called PVIF, present value interest factor. 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 This is for irregular. This is for irregular cash flows. This is a method of discounting used for irregular cash flows. Irregular cash flows. And what is the formula? The formula of getting PV, present value interest factor, is 1 plus R, close your bracket, raised to negative n, This is the formula of PV. R is the cost of capital, or the risk-free rate. So now, when we look at these cash flows, we are going to apply this formula of discounting. So let's have PV. So PV. So which rate are we going to use? So my good people, normally, when you are using certainty equivalent approach to determine the net present value, the discounting rate should always be the risk-free rate. You are supposed to use the risk-free rate. Always remember that. This is a bit different from the normal NPV computation. Here, we are going to use the risk-free rate, to discount. We are going to use the risk-free rate to discount, not the cost of capital, and not the cost of capital as usual. Under certainty equivalent approach, not this. Under certainty equivalent approach, we can have it as an NB here. So let's write it here, NB. So we are saying under certainty equivalent approach. Under certainty equivalent approach in determining NPV. We normally use risk-free. We normally use risk-free rate of return. We normally use risk-free rate to discount. We normally use risk-free rate to discount. So here, our rate will be PV at 5%. The risk-free rate. Maybe if the examiner wants to confuse you, he can give you, or the examiner can give you the risk-free rate as 5%. Then the examiner can also give you the cost of capital, maybe still at 5%. So here, so many students will be dropped. So many students will be dropped under the bus, for this paper. Some of you will use the risk-free rate, and others will use the cost of capital to discount the cost of capital, because they are used to using cost of capital to discount when determining the NPV. But under certainty equivalent approach, kindly use the risk-free rate to discount. So let me wrap this one. So 5%. So the formula is here, 1 plus R raised to negative n. So for first year, it will be PVIF which is equals to 1 plus r raised to negative n. So it will be 1 plus 5% is 0.05 raised to negative 1. So that will be 1.05 raised to negative 1. So what is 1.05 raised to negative 1? What is 1.05 raised to negative 2? What is 1.05 raised to negative 3? What is 1.05 raised to negative 4? Let's get our discounting factors here. Let's get our discounting factors. Let's get our discounting factors. Allow me to wrap this part also, because the point, I believe, is at home. The point is at home. Let me wrap this. The point is already at home with you guys. So 1.05 raised to negative 1. Take your calculator and press 1.05 raised to negative 1. What are we getting there? 0.9524. 0.9524. 0.9524. What about for year 2? Take your calculator again and press 1.05 raised to negative 2. Negative 2. What are we getting? 0.9070. 0.9070. 0.9070. We said that these discounting factors, we are supposed to have them in 4 decimal places. That will be very much okay. That will be very much okay in 4 decimal places. That will be very much okay. That will be very much okay. That will be very much okay. 0.9070. 0.9070. What about, let me write this properly. 0.9070. 0.9070. 0.9070. 0.9070. 0.9070. What about for year 3? Year 3, it will be 1.05 raised to negative 3. Raised to negative 3. What are we getting? 0.8638. 0.8638. 0.8638. 0.8638. What about for year 4? It will be 1.05 raised to negative 4. Negative 4. What are we getting? 0.8227. 0.8227. Now, can we get our present values? Can we get our present values? Can we get our present values? How do we get our present values? We will take the certain cash flows. We will take the certain cash flows times the discounting factors. Times the discounting factors. So can we do for year 1? Can we get the figure for year 1? We will take 950,000. This is 950. Let me write it properly. This is 950. 950. 950. 950. This is 950. This is 950. I hope you can see that figure clearly. 950. 950 times the discounting factor will be 0.9524. So let us take 950,000 times 0.9524. What are we getting as our present value? 904, 904, 904, 780, 780, 904, 780. What about for year 2? We'll take 1,200,000 times 0.9070. What are we getting? 1088,400. 1088,400. 1088,400. 1088,400. What about for year 3? We'll take 1,400,000 times 0.8638. What are we getting? 1209,320. 1209,320. 1209. 320. 320. What about for year 4? We will take 1,500,000 times 0.8227. What are we getting? 1234,050. 1234,050. 1234,050. So what is our total? What is our total present value? What is our total present value? We sum all these, we sum all this, we sum all this, we sum all this present value to get our total. So our total will be 904,780 plus 1088,400 plus 1209,320 plus 1234,050. So what is our total present value? What is our total present value? We are getting 4,436,550. 4,436,550. So how do we get NPV? How do we get net present value? How do we get net present value? Net present value is given by present value minus initial outlay. Minus initial outlay. You can highlight this important formula. You can highlight this important formula. Net present value is equals to present value minus initial outlay. And this is our total present value. So we are going to less the initial outlay, in which from the question we have been given the initial outlay there from the question, as we are told Jenga Limited intends to invest 5 million in that project. So that is our initial outlay, 5 million. So we are going to deduct 5 million here, 5 million, 5 million. So when we less the initial outlay, we are going to get our net present value. So what is our net present value? We are going to take 4,436,550 minus 5 million, minus 5 million. We are getting 563,450, but negative. So when you get a negative NPV, what is its interpretation? The interpretation of a negative NPV is that that project is not viable. That project is not viable. So when you get NPV, which is negative, you write to the examiner that this project is not viable. This project is not viable. This project is not viable. But when you get an NPV which is positive, that means that project is viable. That project is viable. So that is it for Roman number 1. That is it for Roman number 1. We were required to get the NPV of the project. So the NPV of that project is 563,450, but negative, which is not viable. So for Roman 2, we are told to advise the management on whether to invest in the project or not. So our advice now will be this. Our advice now will be this. Because the NPV is negative, the management advise. The management should not invest. The management should not invest. The management should not invest in the project, should not invest in the project because it is not viable. Because it is not viable, as its NPV is negative. And that is it. You get your full marks. With that. You get your full 12 marks by doing this. So that is it. That is it for today. That is it for today. That is it for today. I hope you have enjoyed this session. I hope you have enjoyed this session. I hope you have enjoyed this session, and we shall continue to meet, and we shall continue to meet, and we shall continue to meet. Thank you very much. Thank you very much. God bless you. God bless you. Without forgetting, you have been receiving this class from RCM Online College. We are offering KNEC Diploma courses. We are offering KNEC Diploma courses here through Zoom. You can study with us to pursue diploma in business management, to pursue diploma in investment management, to pursue diploma in human resource management, and we will be able to register you as a private candidate to those centers where these examinations will be done. So we are offering affordable rates of 1,000 per unit, 1,000 per unit. So we welcome you all to join us, and we promise that you will not regret joining us. So spread the word out there, for all of you who wants to pursue diploma courses. RCM Online College is the place to be. Thank you very much. See you. Bye. Thank you.